Good afternoon, students. This is Arvind, Assistant Professor, Department of Trucking, Railway Safety, Travel. So, in the previous class, I discussed about effect of excitation and effect of mechanical input on parallel operation of alternators and load changing of alternators and the infinite bus work on the alternator and the infinite bus work. And now, in this class, I am going to discuss determination of sub-transient, transient, and steady-state reactances and some numerical problems on parallel operation of alternators. Firstly, I will discuss the determination of sub-transient, transient, and steady-state reactances. So, in this one, whenever a three-phase short circuit occurs at the terminals of an alternator, the current in the armature circuit increases suddenly to a large value. Okay, so suppose if we take a three-phase alternator, so in this one, short circuit occurs at the terminals of an alternator. That means the current in the armature circuit increases. Okay, the current in the armature circuit increases, not in the field. Okay, it increases suddenly, suddenly to a large value, and since the resistance of the circuit then is small, so whenever the armature circuit increases, at the same time the resistance of the circuit is small as compared to its reactance. Okay, so compared to the reactance of the circuit, the resistance is small, then the current is highly lagging and the power factor is approximately 0. Okay, the current is highly lagging and the power factor is approximately 0. So due to this sudden switching, as analyzed in the previous section, there are two components of current. So previously I discussed some topics. So in that one, we have two components, one is AC component and another one is DC component. Okay. So here the DC component is also called decay. Okay. So the current oscillogram shown in the figure, that is this one. This is the current oscillogram as a function of time. Okay. So these are the current waveforms. Okay. This one is also called current oscillogram. Okay. The current oscillogram shown in the figure. So in this one, the rotor winding acts as a secondary of the transformer. So the rotor winding acts as the secondary of a transformer, for which the primary is the stator winding. So here I am taking the rotor winding as the secondary of a transformer and the primary winding as a stator winding. Okay, so similarly, in case the rotor has the damper winding, okay, if we take the damper winding in the rotor, so fixed on its poles, so the damper winding is fixed on the poles, then the whole system will work as the three-winding transformer. That means previously we have the rotor winding and stator winding, and now we have damper winding. So that means totally we have three windings of the transformer, okay, in which stator is the primary and the rotor winding and the damper winding from the secondaries of the transformer. Okay. So at this instant of the short circuit, there is mutual coupling between the stator winding, rotor winding and damper winding. So this is at the instant of short circuit. Okay, at the instant of short circuit, there is mutual coupling between these three windings, those are stator winding, rotor winding and the damper winding, and the equivalent circuit is shown in this figure. So this is the equivalent circuit for three cases. First one is for the sub-transient and second one is for the transient and third one is for the steady state. So before going to this one, we have the current oscillogram. So from this one we have to calculate the sub-transient, transient and steady state currents first, and after that we have to calculate the sub-transient, transient and steady state reactances. So firstly we will see the oscillogram variation as a function of time. So here I am taking x-axis and y-axis. On the x-axis I am taking the time, in the y-axis I am taking the current. So here I am providing 4 points. So one is O, that is the origin point, and another one is A, and another one is B, and another one is C. By using these 3 points, we have to find out the sub-transient, transient and steady state current. So I drawn a sine wave. So initially it is in the increasing order. So after that it is slightly decreasing, and finally we have this waveform. So here I am indicating the 3 points along with the O point. So O is the origin point. Next we have A, B, C. So in this diagram we have the totally two curves and two dotted lines we have. So in that one, the duration of the OA is called sub-transient current, OA. So that OA is called sub-transient current. So O is the origin and next we have the sine wave. So in that way we draw one curve touches to the high point, that is the maximum point, that is the A point. Okay. So in this one, the duration between O and A is called sub-transient current. And next I draw one curve, it touches the same curves, but a slight difference is there. So that OB point is known as the transient current, and then we denoted with the dotted lines for the same curve, but slight difference is there. So that OC point is called steady state current. So like this we have to find out the sub-transient, transient and steady state currents. And next I am using these three equivalent circuits. So in the first circuit we have the damper winding and rotor winding and stator winding, all are present with the reactance of the circuit. Okay, so by using this, so since the equivalent resistance of the damper winding when referred to the stator is more as compared to the rotor winding, so in this one the damper winding, that is XV, reactance XV, so the equivalent resistance of the damper winding when referred to the stator, that is stator winding, is more as compared to the rotor winding. Okay, the resistance of the damper winding when referred to the stator is more as compared to the rotor winding. Then the time constant of damper winding is smaller than the rotor field winding. Okay, the time constant of damper winding is smaller than the rotor field winding. So that means here the effect of damper winding and eddy current in the pole phases disappears after the first few cycles. Okay, so in the first cycle, that is in the first equivalent circuit, we have three windings: stator winding, rotor winding and damper winding. And so whenever the effect of damper winding and the eddy current loss in the pole phases disappears after the first few cycles, so accordingly the equivalent circuit after the first few cycles reduces to 1 as shown in this diagram. So this one, so in this one the damper winding is neglected, only we have stator and rotor winding. Okay, so that is in the second diagram. And after a few more cycles, depending upon the time constant of the field winding, okay, depending upon the time constant of the field winding, the effect of the DC component will die down. Okay, the effect of the DC component. So actually in the first slide I said that we have two components, one is AC component and another one is DC component. So based on this, after a few more cycles, depending upon the time constant of the field winding, the effects of the DC component will die down and steady state conditions will prevail for which the equivalent circuit is shown. Okay, that is in the third diagram, third equivalent diagram. So in this one we have only stator winding. Okay, and the effect of damper winding and rotor winding is neglected. Okay, so in this way we have to calculate the three reactances: transient, sub-transient and steady state reactances. So the reactance in the initial stage, okay, the reactance in the initial stage corresponding to first diagram is called the sub-transient reactance, and corresponding to the second one it is called as transient reactance, and the steady state reactance is the synchronous reactance. Okay, like that we will find out the sub-transient, transient and steady state reactances. Okay, so up to now we completed the theory part of this chapter, and coming to the problems. So these here I am telling the this is in three problems. These three problems are for the parallel operation of alternators. Okay, so coming to the problem number 1. So in this one, the two single phase alternators operating in parallel. So here I am taking two single phase alternators, both are operating in parallel, have induced EMFs, that is E1 and E2, have induced EMFs 220 at an angle of 0 and 220 at an angle of 10 degrees. Like that we have the EMFs, and we have the respective reactances, that is Z1 and Z2. Why? Because here we are using two alternators. So Z1 value is J3 ohms and Z2 value is J4 ohms. Okay, next by using this data we have to calculate the terminal voltage, that is V bar, and currents I1 bar and I2 bar, and the power, that is P, for power developed by each of the alternators. That means we have to calculate the power for each alternator. Actually we have the two alternators, that means we have to calculate the P1 and P2 value. So power developed by each of the alternators to a load resistance of 6 ohms. So load resistance is nothing but the Z. So here the given Z value is 6 ohms, J6 ohms. Like that they given the data, and by using the data we have to find out the terminal voltage, currents I1 and I2, and powers P1 and P2. So note down the given data first. So in the problem they given EMF E1 and E2. So E1 bar is equal to 220 at an angle of 0, and E2 is 220 at an angle of 10, and Z1, that is J3 ohms, and Z2 J4 ohms. But here I did a mistake, so I didn't mention the Z2 value in this one, but we have the value that is Z2 bar is equal to J4 ohms, and in the problem also the given load resistance, that is J6 ohms. So please change Z value as J4 ohms and Z value as J6 ohms. Okay. And next, by using this data, we have to calculate the I1, I2, and V and P. So we know that firstly we have to calculate the I1, I2 values. So from the parallel operation of two alternators, okay, parallel operation of the alternators, we determine at that time I1 and I2 values. So here I am using the formulas of that one. So to find out the I1 value for this problem, we have to take the formula, that is I1 bar is equal to E1 bar minus E2 bar into Z bar plus E1 Z2 bar by Z bar of Z1 plus Z2 bar plus Z1 Z2 bar. This is the formula to find out the I1 current in this one. So, and if you want to find out the I2 value, we have E2 minus E1 into Z bar plus E2 Z1 bar by Z bar of Z1 bar plus Z2 bar plus Z1 Z2 bar. So in the problem they already given E1 value and E2 value, and Z1 value and Z2 value and Z value. So please substitute those values into this formula, that is I1 is equal to E1 bar minus E2 bar into Z bar plus E1 bar into Z2 bar by Z bar of Z1 bar plus Z2 bar plus Z1 into Z2 bar. So in the problem they given E1 bar as 220 at an angle of 0 minus E2 is 220 at an angle of 10 into total Z value is 6 ohms into 6 plus E1 value is 220 at an angle of 0 into Z2 value is J4 ohms divided by Z value is 6 into Z1 bar value is J3 ohms plus Z2 value is J4 ohms plus Z1 into Z2, that is J3 into J4. So after simplifying the above equation, we have, so 220 at an angle of 0 minus 0 means 220 minus, so 220 at an angle of 10, so actually it is in the polar form. 220 at an angle of 10 means it is in the polar form. So please convert this polar form into rectangular form. We have the value for the 220 at an angle of 10 degrees in the rectangular form is 216.65 plus J38.20 whole into Z value is 6 plus, so in this one 220 at an angle of 0 into, in this one they given the rectangular form, that is J4. Okay, so please convert this J4 into polar form. After converting it into polar form, we have the value, that is 4 at an angle of 90 degrees divided by 6 into, so here we are adding J3 plus J4 and finally we have the J7 plus, so here I am converting J3, that is in the rectangular form, J3, so it is converted into polar form, and finally we have 3 at an angle of 90 into 4 at an angle of 90. So 4 at an angle of 90 is the polar form of rectangular form of J4 ohms. Okay, that is 3 at an angle of 90, that is for the J3, and 4 at an angle of 90, that is for the J4. And after simplifying the equation, we have the value, that is, so after simplifying that one, that is 220 minus 216.65 plus J38.20 into 6. So after simplifying this one, we have 3.35 minus J38.20 whole into 6 plus 220 into 4 means we have 880 at an angle of 90, at an angle of 90 divided by, so we have 6. So J7 means it is in the rectangular form. Please convert the J7 into polar form. We have 7 at an angle of 90 degrees in the polar form for the J7 plus 3 into 4 means 12. So 12 at an angle of 180 degrees, that is 90 plus 90. That is 180. And after simplifying this, we have, so 6 into 3.35 means, how much we have? So 38.42 minus J30. So after simplifying this one, that is 3.35 minus J38.38. So actually it is in the rectangular form. So please convert this rectangular form into polar form. And we have the polar form of 3.35 minus J38.28 is 38.42 at an angle of minus 84.99 whole into 6 plus 88 at an angle of 90 divided by. So here I am converting this 6 into 7 means we have 42. So 42 at an angle of 90 plus 12 at an angle of 180. So please convert this into rectangular form, and finally we have the J42 minus 12. This is the rectangular form of this one. And next we have, so after simplifying this one, we have 6 into 38.42 means 230.52 at an angle of minus 84.99. Okay. Plus 880 at an angle of 90 divided by minus 12 plus J42. Okay. And next I am taking the rectangular form of this one, that is 230.52 at an angle of minus 84.99. We have 20.13 minus J229.60, that is the rectangular form of this one, plus J. So 880 at an angle of 90 means we will write it as J880. In the rectangular form, it is J880 divided by. So after converting this minus 12.J42 into polar form, we have 43.68 at an angle of 105.94. And after simplifying this one, we have 20.13 plus J650.37 divided by 43.68 at an angle of 105.94 degrees, that is equal to. And finally, please convert this rectangular form of 20.13 plus J650.37. We have the polar form, that is 650.68 at an angle of 88.22 degrees divided by 43.68 at an angle of 105.94. After simplifying this one, we have the 14.89 at an angle of minus 17.72 degrees. This is I1 value for the given problem. So this is the solution for the I1. And next, coming to the solution of I2, that is, you know already the formula to calculate I2, that is I2 is equal to E2 minus E1 into Z bar plus E2 Z1 by Z bar of Z1 bar plus Z2 bar plus Z1 bar into Z2 bar. So that is equal to, you know the equations, that is, you know the values of E1, E2, Z1, Z2 and Z. Please substitute those values into this equation. So E2 means 220 at an angle of 10 minus E1 means 220 at an angle of 0 whole into Z value is 6 plus E2 value is 220 at an angle of 10 into Z1 value is J3 divided by Z value is 6 into Z1 value is J3 plus Z2 value is J4 plus Z1 into Z2 means J3 into J4. So after simplifying this one, we have, so please convert this 220 at an angle of 10 into, actually it is in the polar form, please convert that into rectangular form. So after converting this into rectangular form, we have 220 at an angle of 10, that is in the rectangular form is 216.65 plus J 38.20 minus 220 at an angle of 0 is nothing but the 220. So whole into 6, that is the Z value, plus 220 at an angle of 10 into, please convert J3, that is in the rectangular form, please convert that into polar form. We have 3 at an angle of 90 divided by 6 into J3 plus J4 means J7 plus 3 into, so please convert J3 and J4, actually these two in the rectangular form, please convert these two into polar form, and finally we have J3 in the polar form is 3 at an angle of 90 into J4 in the rectangle in the polar form is 4 at an angle of 90, and simplify this one, and we have, so after simplifying the first one, that is 216.65 plus J38.20 minus 220, after simplifying this one, we have minus 3.35 plus J38.20 into 6 plus 220 into 3 means 660. So 660 into 660 at an angle of 100, that means 90 plus 10, that is 100 divided by So 6 into 7 means 42. So 42J. So please convert that 42J into rectangular polar form. We have 42 at an angle of 90 plus, so 3 into 4 means 12. So 12 at an angle of 90 plus 90 means 180. So that is equal to, after simplifying this we have, so please convert this minus 3.35 plus J38.20 into polar form, and finally we have 38.34 at an angle of 95.01 as that polar form for minus 3.35 plus J38.20 whole into 6 plus, so 660 at an angle of 100, actually it is in the polar form. Please convert this into rectangular form, and finally we have minus 114.60 plus J into 649.97 divided by J42 minus 12. So after simplifying this one we have, so 38.34 into 6 means 230.04 at an angle of 95.01 plus 114, that is minus 114.60 plus J649.97. So by minus 4.J42. So after simplifying this we have, so that means minus 20.08 plus J 229.16, that is for the 230.04 at an angle of 95.01. After simplifying this polar form into rectangular form, we have minus 20.08 plus J 229.16 minus 114.60 plus J649.97 by 43. So please convert this minus 12.J42, actually it is in the rectangular form. Please convert into polar form. We have 43.68 at an angle of 105.94, and after simplifying this we have I2 bar is equal to minus 134.68 plus J879.13 in the numerical form, so that means in the numerator form, and in the denominator form we have same, that is 42.68 at an angle of 105.94. And finally, please convert the numerical in the numerator we have minus 134.68 plus J879.13, that is in the rectangular form. Please convert this into polar form. We have 889.38 at an angle of 98.70 divided by 43.68 at an angle of 105.94. So after simplifying this one we have 20.36 at an angle of minus 7.24 degrees. This is the I2 value. So this is the first case, and coming to the second case, that is the third case. In this one we have calculate the total current, that is I is equal to I1 plus I2. So actually we calculate the I1 value and I2 value. Please substitute those values into this one, and I1 value is 14.89 at an angle of minus 17.72 degrees plus I2 value is 20.36 at an angle of minus 7.24. So please convert these polar forms into rectangular form. So the rectangular form of I1 is 14.19 minus J4.53 plus the rectangular form of I2 is 20.19 minus J2.56, and after simplifying this we have 34.38 minus J7.09. So for this rectangular form, please convert this into polar form. We have 35.10 at an angle of minus 11.65 degrees, and after that we have to calculate the terminal voltage. That is, you know the formula, that is V bar is equal to I bar into Z bar. You know already I bar and Z bar values. So please substitute those values into this one. So you know already I bar is 35.10 at an angle of minus 11.65 into Z value they already given, that is 6 ohms, that is 6 at an angle of 0. So finally we have 35.10 into 6 means 210.6 at an angle of minus 11.65. This is the terminal voltage value. And finally we have to calculate the power in each alternator, that is P1 is equal to V into I1 cos phi 1. Okay. So in this one, V means just now we calculate, that is 210.6 into I1 is 14.89 into cos of phi 1. So phi 1 means minus 17.72 degrees. So actually we calculate 14.89 at an angle of minus 17.72. So please treat this one as phi 1. So that is cos of minus 17.72, and after simplifying this one we have 2989.06 watts, that is 2.98 kilowatts. And similarly P2 is equal to V into I2 into cos phi 2. We already calculated V value and I2 value and phi 2 value. Please substitute that into this one. So V value is 210.6 at an angle 210.6 into I2 value is 20.36 into cos of phi 2 is in the I2 value we have the angle that is minus 7.24. Please substitute that one here. And finally we have 4253.72 watts, that is 4.25 kilowatts. This is the solution for the problem number 1. Okay. And coming to the problem number 2. So here also we are taking two single phase alternators operating in parallel and supply load impedance of 3 plus J4 ohms. Load impedance of 3 plus J4 ohms, and if the impedance of the machine is 0.2 plus J2 ohms and EMFs are 220 plus J0 and 220 plus J0, and calculate terminal voltage V, current I1 I2, output for P. So similar to the previous problem, we have calculated the same parameters, that is terminal voltage, current I1 I2, output for P. Okay, firstly we have to note down the given data. So from this in the problem they already given EMFs, that is both are equal, that is E1 and E2. So E1 bar is equal to E2 bar is equal to 220 plus J0. So please convert that into polar form. We have 220 to an angle of 90 degrees, and they already given the impedances of the machine, that is Z1 and Z2, both are equal, that is 0.2 plus J2. So please convert this into polar form. We have 2 at an angle of 84.28 degrees, and in the problem they already given load impedance, that is Z. So Z is equal to 3 plus J4 ohms. Please convert this rectangular form into polar form, and we have 5 at an angle of 53.13 degrees. So by using this data we have to calculate the V, I1, I2 and P. Okay, so similar to the previous one, we have to calculate the I1 and I2 values. So from the parallel operation of the alternators, in that one we derived I1 and I2 values. Please take those formulas into this one to calculate the I1 and I2. That is I1 bar is equal to E1 bar minus E2 bar into Z bar plus E1 Z2 bar by Z bar of Z1 plus Z2 bar plus Z1 Z2 bar, and I2 bar is equal to E2 bar minus E1 bar into Z bar plus E2 bar into Z1 bar by Z bar of Z1 bar plus Z2 bar plus Z1 bar into Z2 bar. So in this one we are calculating the first I1 value and next I2 value. So I1 bar is equal to, we know the formula, that is E1 minus E2 into Z plus E1 Z2 by Z of Z1 plus Z2 plus Z1 Z2. So in the problem they are already given E1 E2 values and Z values, and E1 Z2 values and Z of Z value is given. So please substitute those into this one. So you know already that is E1 bar minus E2 bar, you know already E1 bar value, that is 200 at an angle of 0. Please substitute this one plus. So you know already that is Z2 bar value. So we already calculated, that is E1 E2 value, that is 200 at an angle of 90. In the place of E1 minus E2 and that one, we have to substitute that one 220 at an angle of 90 plus. So E1 Z2 bar, so that is E1 is 220 at an angle of 90. Okay, 220 at an angle of 90, and Z2 is 2 at an angle of 84.28. So please substitute here. Okay, next we know the Z value. We know the Z value, that is 5 at an angle of 53.13. Please substitute here into Z1 bar plus Z2 bar, they already given. So Z1 is 0.2 plus J2 into, so plus here not into, that is plus Z2 value is 0.2 plus J2 and plus Z1 bar into Z2 bar, that is we already calculated Z1 value and Z2 value, that is 2 at an angle of 84.28. Please substitute here, and after that we have 220 into 2 means we have 440. So 440 into 84.28. So here E1 bar minus E2 bar into Z bar is 0. Okay. So please neglect that one, and we have only E1 Z2 bar. So you know already E1 value, that is 220 at an angle of 0. Okay. So plus 2 at an angle of 84.28, that is we have 440 into, so here it is into not plus. Okay, in the numerator please convert this plus into product, that is into multiplication into. So that is 220 into 2, that is 440 at an angle of 84.28 by, so 0.2 plus 0.2, that is 0.4 plus J2 plus J2, that is J4 into 5 into 5 at an angle of 53.13 plus 2 into 2 means that is 4. 4 at an angle of 84.28 plus 84.28 means 168.56. Okay, so after simplifying this we have 440 at an angle of, so 440 at an angle of 84.28 divided by, so after simplifying this one we have, that is converting this 0.4 plus J4 rectangle from the polar form, we have that is 4.01 at an angle of 84.28 into 5 at an angle of 53.13. So after converting this 4 at an angle of 168.56 degrees into polar rectangular form, that is minus 3.92 plus J 0.79, and after converting this one we have the rectangular form of 20.01 at an angle of 137.41. We have the polar form of this one, that is 20.05 at an angle of 137.41 plus minus 3.92 plus J 0.79. So after converting this 20.05 at an angle of 137.41 rectangular form, we have minus 14.76 plus J 13.56 minus 3.92 plus J 0.79, and finally we have the value, that is I1 bar is equal to 440 into 440 at an angle of 84.28 by, after simplifying the denominator we have minus 18.68 plus J 14.35. So after converting the denominator into rectangular form, sorry, polar form, we have 23.55 at an angle of 142.46. So already the denominator in the polar form, and finally we have the I1 value, that is 9.84 minus J 15.87 amperes. This is I1 value, and I2 value is, so I2 bar is equal to E2 bar minus E1 bar into Z bar plus E2 bar into Z1 bar plus Z bar of Z1 bar plus Z2 bar plus Z1 bar into Z2 bar. So substitute E1, E2, Z2 and Z1, Z2 values here. So here E2 minus E1 means into Z bar means it is 0. Why? Because E1 and E2 same value, that is 220. So please neglect that one, and plus that is 0, that is E2 minus E1 bar into Z bar value is 0. Plus we have E2, that is E2 means 220 at an angle of 0 into Z1 bar is, so already we calculated, that is 2 at an angle of 84.28. It is also in this one also, please replace plus by multiplication, that is into, okay, divided by Z value is 5 at an angle of 53.13 into Z1 is 0.2 plus J2 plus Z2 value is 0.2 plus J2 plus Z1 bar is 0. So already we converted the rectangular into polar, that is 2 at an angle of 84.28 into 2 at an angle of 84.28. So that is I2 is equal to, in the numerator we have 220 into 2, that is 440 at an angle of 84.28 divided by, so 0.2 plus 0.2 is 0.4, okay, plus J2 plus J2, that is J4 into 5 at an angle of 53.13 plus 2 into 2 is 4 at an angle of 168.56. So that is equal to 440 at an angle of 84.28 divided by, so please convert the 0.4 plus J4 into polar form, that is 4.01 at an angle of 84.28 into 5 at an angle of 53.13 minus, after converting this 4 at an angle of 168.56 into rectangular form, we have minus 3.92 plus J 0.79. So please substitute that one here. So in the denominator, please convert this, multiply 4.01 into 5, that is 20.05 at an angle of 137.41 minus 3.92 plus J 0.79. So after simplifying this we have minus, so after converting this 20.05 at an angle of 137.41 into rectangular form, that is minus 14.76 plus J 13.56 minus 3.92 plus J 0.79. So after simplifying the denominator, we have minus 18.68 plus J 14.35. Please convert this one into polar form, that is 23.55 at an angle of 142.46. And finally we have I2 value, that is 9.84 minus J 15.87 amperes. So same value for the I1. Why? Because here Z1 Z2 value is same, even E2 value is same. Okay, Z value is same. That's why we have the same current values in the one. Okay, next we have calculated the terminal total current I, that is equal to I is equal to I1 plus I2. So that is 9.84 minus J 15.87, that is I1, plus I2 is 9.84 minus J 15.87, same value. So after simplifying this one, we have 19.68 minus J 31.74. It is in the rectangular form. Please convert this into polar form. We have 37.34 at an angle of minus 58.19 degrees. That is the current value in the alternator. And the terminal voltage, you know already the formula, that is V bar is equal to I bar into Z bar. So just now we calculated the I bar, that is 37.34 at an angle of minus 58.19 into Z value they already given in the problem, that is 5 at an angle of 53.13. So after simplifying this one, we have 186.7, that is 37.34 into 5, that is 186.7 at an angle of minus 5.06, that is minus 58.19, minus that is 53.13 minus 58.19. Finally, we have minus 5.06, and this is the terminal voltage value. And next, we have to calculate the power for both alternators, that is P1 is equal to V into I1 cos phi 1. So in the problem, we calculated V value, that is 186.7 into I1 value is 9.84 into cos of phi 1 value, that is which one, that is 53 point, sorry, minus 58.18. Okay, so please substitute here, and finally we have 188.82 watts, that is 1.83 kilowatts. Okay, so I1 value, after counting this one, we have the angle, that is minus 58.18. So 1.83, and similarly P2 is equal to V into I2 cos phi 2. So V value is 196.7 into 18.68. So actually this 18.68 is the rectangular polar form of 9.84 minus J 15.87. After converting this into polar form, we have 18.68 at an angle of minus 58.18. So in this one, phi 2 value is minus 58.18, and we have 188.82 watts, that is the P2, and that is equal to 1.83 kilowatts. Okay, this is the power values. This is the solution for the problem number 2. And coming to the problem number 3. So they given the EMF of two alternators are, that is E1 and E2. So E1 is 3000 at an angle of 220 degrees, and E2 is 2900 at an angle of 0 degrees. Okay. So those are the EMF, that is voltages E1, E2. E1 is 3000 at an angle of 20 degrees, and E2 is 2900 at an angle of 0 degrees. So, and they also given synchronous impedances, that is 2 plus J20 and 2.5 plus J30. Okay, 2 plus J20 ohms per phase and 2.5 plus J30 ohms. So I not mentioned the Z2 value. So actually in the problem they given, but I didn't mention here. So that is also here, that is 2.5 plus J30 ohms, that is Z2 value, and they already given the load impedance, that is Z is 10 plus J4 ohms, and by using these data we have to calculate the circulating current. Okay, so in the previous sections we derived the circulating current formula. Please use that the formula into here. So first we have to note down the given data. So from the data, from the given problem, we have to mention the data, that is the given the load impedances or synchronous impedances. Z1 is 2 plus J20 ohms. So actually it is in the rectangular form. Please convert this into polar form. We have 20.09 at an angle of 84.28 degrees, and Z2 they also given, that is 2.5 plus J30 ohms. So it is actually in the rectangular form. Please convert this into polar form. We have 30.10 at an angle of 85.23 degrees, and load impedances they already given, that is Z1 is equal to 10 plus J4 ohms. Actually it is in the rectangular form. Please convert this into polar form. We have 10.77 at an angle of 21.80 degrees, and they already given the load impedance EMF, so that is E1, E2. So E1 they already given in the rectangular form, that is for polar form, that is 3000 at an angle of 20 degrees. So please convert this into rectangular form, that is 2219.07 plus J1026.06, and E2 they already given in this one, that is 2900 at an angle of 0 degrees, that is equal to, actually it is in the polar form. Please convert this into rectangular form. We have 2900 plus J0 And this is the formula to calculate the circulating current. So we already derived this circulating current formula in the previous sections. So that is IC bar is equal to E1 bar minus E2 bar into Z bar by Z bar of Z1 bar plus Z2 bar plus Z1 bar into Z2 bar. So that is equal to the already given in the problem E1, E2, Z and Z1 plus Z1 and Z2. Please substitute those values into this formula. So here E1 is the already given, that is 2219.07 plus J 1026.06 minus E2 is 2900 plus J0 into Z bar is the already given, that is 10.77 at an angle of 21.80 divided by Z bar the already given, that is 10 plus J4. Okay, sorry, that is Z1. So in the problem they already given the Z1 and Z2, that is this one, 2 plus J20 plus 2.5 plus J20, that is Z1, Z2, and Z is 10 plus J4. So after converting this polar form, we have these values. So actually we given 2 plus J20, that is Z1, Z2 is 2.5 plus J20, Z is 10 plus J4, add here, plus Z1 bar into Z2 bar, that is 20.09 at an angle of 84.28 into 30.10 at an angle of 84.23. So after this we have taken these values, that is 10.77, Z bar is 10.77 at an angle of 21.80 into 4. So 2 plus 2.5 is 4.5 plus J20 plus J30 is J50 plus. So 20.09 into 30.10, that is 604.70 at an angle of 169.51 degrees. So after simplifying the numerator we have 1029.24 at an angle of 94.5 into 10.77 at an angle of 21.80 divided by 10.77 at an angle of 21.80 into, after converting this 4.5 plus 850 rectangular form into polar form, we have 50.20 at an angle of 84.85 plus, after converting this 604.70 at an angle of 169.51 degrees into polar rectangular form, we have minus 594.59 plus J 110.09. So simplifying the above equation, that is the numerator form, we have 11,084.91 at an angle of 160.3 divided by, so 540.65 at an angle of 106.65 minus 594.59 plus J 110.09. So after simplifying the denominator we have minus 154.90 plus J 517.98 minus 594.59 plus J 110.09. So that is equal to minus 749.49 plus J 628.07. So please convert this into polar form. The denominator, the value is 997.85 at an angle of 140.03. After simplifying the above equation, we have IC bar is equal to 11.33 at an angle of minus 23.730. Actually it is in the polar form. Please convert this into rectangular form. We have 10.37 minus J 4.55 amperes. Okay, like this we have to solve this problem. Okay, in the next class we have to solve the remaining problems in this chapter. Okay, thank you. Thank you for watching this video.